Welcome to day 4 of our 15-day beginner data science sprint. In the previous lessons, we understood the data science workflow, revised the Python required for data analysis, and learned how NumPy helps us perform numerical operations efficiently. Today, we are moving to one of the most widely used tools in data science, Pandas. By the end of this lesson, you will be able to load a CSV file into Python and confidently inspect the data inside it. You will not need to read thousands of rows manually. Instead, you will learn a systematic process for understanding a dataset before beginning any analysis. Imagine that someone gives you a CSV file containing the performance records of 10,000 students. The file contains their marks, attendance, study hours, and other details. Would you open the file and read all 10,000 rows one by one? Of course not. So the question for today is, how can we understand a large CSV file without reading every single line? This is where pandas become useful. Using just a few commands, pandas can tell us how many rows and columns the dataset contains, what the column names are, what kind of data each column stores, whether values might be missing, what the minimum, maximum, and average values are, what the first and last few records look like. Today we will learn how to perform this initial inspection. By the end of this lesson, you should be able to import the Pandas library, load a CSV file into a data frame, understand rows, columns, and the index, inspect the shape and column names of a dataset, identify the data type of each column, use head, tail, info, and describe, translate technical outputs into simple sentences about the data. The final point is especially important. Running a command is not data analysis. The real skill is understanding what its output tells us. So what is Pandas? Pandas is a Python library used for working with unstructured data. Structured data is usually organized into rows and columns. So let me open Google Colab. So Pandas is a Python library used for working with structured data. And the structured data is usually organized into rows and columns. So examples of structured data is a spreadsheet, a CSV file, a database table, a list of customer orders, a student marks table, a collection of website transactions. The most important object in Pandas is called a data frame. A data frame is a labeled table. So data frame is nothing but a labeled table. It contains rows and columns similar to an Excel sheet. Each column has a name and every row has an index. Let us understand these terms clearly. A row normally represents one observation or record. In our student dataset, one row may represent one student. A column represents one property or feature. For example, student name, mathematics score, attendance, study hours, final result. The index is the label Pandas uses to identify each row. By default, the index usually begins from 0. So there are three things: a row that represents one observation, a column that represents one property or feature, and the index, the label that Pandas use to identify a row. The first row has index 0, the second row has index 1, and so on. Remember that an index is not necessarily the same as a student ID. It is simply the row label currently being used by Pandas. So let us say open this notebook, day 4 Pandas, your first data frame. Create a new notebook and rename the notebook as day 4 Pandas, your first data frame. Now in the first text cell, write this heading. Day 4 Pandas, your first data frame. In the next code cell, we will import Pandas. Before I run the cell, predict what you expect to happen. Will importing pandas immediately display our dataset? The answer is no. Importing pandas only make the library available inside our notebook. Now enter the following code and run the cell. So you will probably not see any output. That is completely normal. This line imports the pandas library and give it the short name PD. Using PD is a common convention followed by Python developers and data scientists. Whenever we want to use a pandas function, we can now begin with PD. For example, PD.read CSV. At this point, pandas is available, but we have not loaded any data yet. So we will use a file called studentperformance.csv. So let me open it. We will upload it from here. So I need to find the file. So I have uploaded. Let me rename it. Now, once we've uploaded, remember that files uploaded directly to a Colab session may disappear when the runtime is reset. For today's lesson, uploading a file directly is sufficient. Once the file is uploaded, we can ask Pandas to read it. So let's write df equals to pd.readcsv studentperformance.csv. Before running this cell, let us predict the result. Will pandas print the complete table automatically? No. The table will be loaded and stored inside a variable called df, but nothing may appear on the screen. Now run the cell. If no error appears, the file has probably been loaded successfully. Let us break down the code. pd.readcsv is a pandas function that reads a CSV file. Inside the parenthesis, we provide the file name, studentperformance.csv. The result is assigned to the variable df. The name df is commonly used as short form of DataFrame. However, it is only a variable name. We could also write students equal to pd.readcsv, student performance.csv. But throughout this lesson, we will use df. At this stage, the dataset has been loaded into memory. However, successfully loading a file does not prove that its contents are correct. We still need to inspect it. So let us view the first few records. Let us write this display df.head. So we are getting five rows. A small table is visible. Look at the output carefully. The number on the far left are the index values. The labels across the top are the column names. Each horizontal line represents one student record. The important point is that head gives us a quick preview of the dataset. It helps us answer questions such as, did the file load correctly? Did the column names look reasonable? Are the values separated into the correct columns? Does the data look similar to what we expected? However, head only shows the first few rows. It does not prove that the rest of the dataset follows exactly the same pattern. For example, missing values or unusual records may still exist later in the file. We can provide a number inside head. For example, we can write display df.head 3. So it will display us the first 3 rows. Similarly, we can display the first 10 rows also. The number inside the parenthesis controls how many rows are shown. Displaying more rows can sometimes be useful, but displaying the entire dataset is usually unnecessary. Our goal is to inspect the table efficiently. Now let us inspect the end of the dataset. So let us write display df.tail. Before running it, predict what you expect. The tail method displays the final 5 rows. Run the cell. Why should we inspect both the beginning and the end? Because sometimes the file contains extra summary rows at the bottom, incomplete records, formatting problems, unexpected values, data from a different category. Looking only at the first 5 rows may not reveal these issues. However, even checking both head and tail does not prove that every middle row is valid. These methods give us a useful preview, not a complete data quality guarantee. Now let us find the size of the dataset. Let us write print df.shape. So pandas print the output with 2 numbers inside parentheses. So it is 10, 5. The exact number may be different depending on your dataset. The first number represents the number of rows. The second number represents the number of columns. So 10, 6 means that the dataset contains 10 rows and 5 columns. 10, 5. We can access these values separately. So let me write print number of rows df.shape 0 and df.shape 1. So df.shape 0 gives us the number of rows and df.shape 1 gives us the number of columns. In plain language, we could say this dataset contains 100 student records and 6 recorded properties for each student. Or in our case, it is 10 student records and 5 recorded uh, pro- uh, properties for each student. This sentence is more useful than simply repeating the output 10, 5. Also remember that the number of rows tells us how many records are currently loaded. It does not prove that the dataset contains every student who should have been included. Let us inspect the column names. So I will write print df.columns. On running the cell, the pandas may display the result as an index object. To convert it into a simpler Python list, let's write print df.columns.toList and parentheses. So you should see a list with the name of every column. The exact names depend on your CSV file. Column names are important because we use them to select and analyze data. A spelling difference matters. For example, attendance is not same as the capital attendance. Python is case sensitive. Extra spaces can also create problems. A column named attendance is different from a column named attendance with a space. In the second case, where an individual space exists at the end. This is one reason why inspecting column names early is important. It prevents incorrect assumptions later. Let us also inspect the data frame index. Let's write print df.index. So as you can see the pattern that when we access some kind of property like df.index, df.columns, df.shape, okay, df.shape. So when we get some kind of output like an object, so range index and then it has some things inside the parenthesis. So this is something we should observe that some of the uh, properties don't require the parenthesis, but some of them require parenthesis. By putting parenthesis in front of them, it means we are calling the function. So we should see something like range index start equal to 0, stop equal to 10, and step equal to 1. This means that pandas is using row levels beginning at 0. The stop value is not included. Therefore, if the stop value is 10, the final index is 9. The index helps pandas identify rows, but once again, it is not automatically a meaningful student ID. It is only the current row label. Later, we may learn how to assign a particular column as the index. For now, the default numerical index is sufficient. Now, every column has a data type. The data type tells Python what kind of values the column contains. Common Panda data types include int64 for whole numbers, float64 for decimal number, object which often represent text, and bool for true or false values. Data types are important because they affect which operations are valid. For example, we can calculate the average of a numerical attendance column, but calculating the average of student names would not make sense. A column may look numerical to us, but still be stored as text. This can happen when a CSV contains values such as 90% or unexpected characters. That is why we should inspect the data types instead of assuming them. So let us inspect the data types. Write print df.types. So let's put a habit to write Python print df.dtypes without any parenthesis. Before running it, look at the table and predict the data type of each column. Will the student name be stored as an integer? Probably not. Will a score column be numerical? Probably yes. Now let's run the cell. So you should see similar to this that student ID is object, study hours float ID, attendance percent is int64, previous score int64, and final score is int64. The exact output depends on the dataset. So translate at least one output into plain language. For example, the attendance column is stored as numerical data, so pandas can perform mathematical operations on it. Or the student name column is stored as text rather than a numerical value. Remember that the data type tells us how pandas currently interprets the column. It does not prove that every value in the column is logically correct. For example, a score of 500 may still be stored as a valid integer, even if the maximum possible score is 100. Data type validation and value validation are two different things. Now let us use one of the most useful inspection methods. Write df.info. Before running it, predict what information it will provide. Do you expect to see every value in the dataset? No. Info gives us a structural summary. Let us now run the cell. The output normally includes the type of object, the number of rows, the index range, the column names, the number of non-null values, the data type of each column, approximate memory usage. Let us focus on the non-null count. Suppose a dataset contains 10 rows. If the attendance shows 10 non-null values, Pandas found a value in every attendance row. But if it shows only 99 or maybe 7 non-null values, then 3 or 1 attendance values may be missing. In plain language, we could say 3 students records do not contain an attendance value. That sentence is much more meaningful than simply saying that non-null values is 7. However, input does not tell us whether the existing values are accurate. It can help identify missing values and structural issues, but it cannot confirm that the data was collected correctly. One more important point: df.info prints information directly. It does not need to be placed inside print. Writing this is sufficient. We don't need to put df.info into print. Now let us calculate a statistical summary. Let us write display df.describe. So before running it, we should have predicted the output. So here for every column, this pandas is displaying. Pandas is displaying count, mean, standard deviation, min 25%, 50%, 75%, and max. Let us understand them one by one. Count tells us how many non-missing values were used. If there are 10 rows, but the count is 8, then 2 values may be missing. Mean is the average value. If the average mathematics score is 76, you can say the average mathematics score is the dataset is 76. Standard deviation STD represents the spread of the value around the average. A smaller standard deviation usually means the values are relatively close to the mean. A larger standard deviation means the values are more spread out. At this stage, you do not need to memorize the formula. You only need to understand that it helps describe variation. Min is the smallest recorded value. The 25% value is the first quartile. Approximately one quartile of the values are at or below this point. The 50% value is the median. Half of the values are at or below this point, and are at or above it. The 75% value is the third quartile. Approximately three quarters of the values are at or below this point. Max is the maximum, is the largest recorded value. Do not run describe and immediately move on. Choose one column and translate its summary into ordinary language. So, for example, student attendance ranges from 62% to 100%, while the average attendance is approximately 84%. The exact sentence should match your output. Also, remember what describe does not prove. It does not prove that the data is accurate. Every student is represented. There are no duplicate rows. There are no impossible values. The data set is unbiased. It does not prove all these things. It only summarizes the values that are currently present. To include both numerical and non-numerical columns, write display df.describe include equals all. So let's close the output. So before running the cell, we should predict what might change. So text columns may now appear in the summary, and that is what has happened. We should include this habit in our coding on Google Colab that before running the cell, we should predict the output. For text columns, you will see information such as count, unique, top, and frequency. Count is the number of non-missing values. Unique is the number of different values. Top is the most frequently occurring value. Frequency tells us how many times that value appears. Some cells may display NaN. In this context, that may simply mean that a particular statistic does not apply to that type of column. For example, calculating the mean of student names would not be meaningful. Now pause the video here. Look at the outputs we have generated. Choose the output what you think is most important. Now explain it in one sentence without using technical jargon. Do not say the shape is 100,6. Instead say the file contains 100 student records and 6 details have been recorded for each student. Do not simply say the attendance DB type is float 64. Instead say attendance is stored as numerical data and can be used in calculations. The purpose of this checkpoint is to separate code execution from actual understanding. Pause the video and write your sentence in a text cell inside the notebook. Now it is time for today's learner challenge. Using the student dataset, find first the number of rows, the number of columns, the data types of the attendance columns. So this is your challenge. Try to solve the challenge without copying the complete solution immediately. First, identify the input. The input is our data frame, DF. Next, identify the record operations. We need one operation that tells us the dimension of the data frame. We also need one operation that tells us the data type of a particular column. Here is the first useful step. df.shape. Use this shape output to find the number of rows and columns. Then select the attendance column and inspect its data type. Pause the video and complete the challenge. Here is one possible solution. Make sure that the column name matches your dataset exactly. If your column is named attendance with a capital A, then write df and in quotes attendance.dtype. You can also solve the first two parts using unpacking, that is number of rows comma number of columns equals df.shape. This is called unpacking. Then print the results using the printer statements. So we have a different data set, that's why it cannot be run. So maybe we can do attendance percent of the attendance percent column. And here we can see. Now add a one sentence interpretation. For example, dataset contains 10 student records and 5 columns, and attendance is sorted as numerical data. Replace the numbers and interpretation with values from your actual output. Now let us discuss the common beginner mistakes. The first mistake is running describe without interpretation. The most important mistake is to avoid is running df.describe and then immediately moving on. The output is not the final analysis. You must translate it into statements about the data. For example, the average score is 74. The lowest attendance is 61%. Most students studied between 2 and 5 hours. The exact statements depend on the output. Second mistake is confusing rows and columns. Remember, df.shape0 gives the number of rows and df.shape1 gives the number of columns. The output order is always rows, comma column. Third mistake is assuming data types are correct. A column may contain numbers but still be stored as text. Always inspect the data type. Do not assume that a numerical looking column is ready for calculations. Fourth mistake is treating the index as a student ID. The numbers on the left side of the data frame are usually index labels. They do not automatically represent actual student IDs. Fifth mistake is assuming head representing the entire dataset. The first 5 rows may look clean while problem exists some elsewhere. Head provides a preview. It does not validate the complete dataset. Sixth mistake is ignoring missing values. Compare the number of rows with the non-null counts shown by df.info. If the non-null count is smaller than the total number of rows, values may be missing. So you can run the complete notebook once again. After each output, stop and ask, what does this tell me? What does this not tell me? Did the result match my expectations? Is there anything unusual that needs further investigation? This habit will protect you from incorrect assumptions later in the project. So let me combine the commands and paste it in a new cell. This gives us a systematic first look at the dataset. But remember that the goal is not to run all the commands as quickly as possible. After each output, stop and ask, what does this tell me? What does this not tell me? Did the result match my expectations? Is there anything unusual that needs further investigation? Let us connect today's lesson to the complete data science workflow. Our data science project normally includes stages such as asking a question, collecting data, cleaning data, exploring data, building a model, evaluating the result, communicating the findings. Today's work sits between data collection and deeper exploration. Before cleaning or analyzing a dataset, we must understand its basic structure. For example, we should know which columns exist, how many records are available, which columns are numerical, which columns contain text, whether values appear to be missing, whether the ranges seem reasonable. Initial inspection helps us decide what to do next. Without it, we may apply the wrong operation to the wrong column or make connections based on incorrect assumptions. So, what did we learn? Let us recap day 4. Today we gained the ability to load and inspect a CSV file using Pandas. We learned that a data frame is a labeled table containing rows and columns. We used p.read CSV to load a CSV file. We used df.head to inspect the first few rows. We used df.tail to inspect the first final few rows. We used df.shape to find the number of rows and columns. We used df.columns to inspect the column names. We used dtypes to inspect data types. We used df.info to understand the structure, non-null counts, and memory usage. And we used df.describe to calculate statistical summaries. Most importantly, we learned that running these commands is only the first step. A data scientist must explain every important output in plain language. Before ending the lesson, answer these two questions. What new capabilities? So answer these two questions. What new capability did we learn? Did we gain on this? how to load a CSV file and systematically inspect its structure using Pandas. And which output should you be able to explain without notes. You should be able to explain what the shape represents, what a data type means, what a non-null count tells us, what the mean, minimum, and maximum represent, what these outputs do not prove. In the next lesson, we will move beyond inspecting the complete table. We will learn how to select specific columns, filter rows, and answer focused questions using the data frame. Complete today's learner challenge, add your one sentence interpretation, and save the notebook as day 4 pandas your first data frame.ipynb. I will see you in day 5.